Okay, Algebra 2. This is the second um, part or the video on quadratic formula. Same note sheet as where the discriminant in the last video, what we talked about there. There's also an additional sheet that goes kind of along with this. That's the quadratic formula. We might go through a couple of these problems as well on here, but it kind of looks like this sheet. Both of these are attached to the Google Classroom link to this assignment. So quadratic formula is just kind of a small little blip down here with two problems on it. And we kind of talked about this already yesterday or in the last video. The entire quadratic formula, negative b plus minus square root b squared minus 4ac all over 2a. They say a cannot be 0, okay? In the last video, we talked about where a, b, and c come from. So we have x squared plus something x plus something, and so your a, b, and c are going to be these numbers here, a, b, c. So they tell us in this little blip, a cannot be 0, because if this guy were 0, we would have 0x squared, which would mean we wouldn't have an x squared, right? This would just be a linear function because we would just have bx plus c. So a has to have a number there, otherwise he's not a quadratic formula or quadratic function to start with, okay? So this is going to be what you're going to use. This formula right here is what we're going to use when you're trying to find the zeros or the x-intercepts and you can't factor. Now you can use it on any type of function, even if you can factor it. But functions, usually if you can factor them, you probably want to go that route and factor them because factoring is a lot easier and less clunky than the quadratic formula. But typically the quadratic formula comes out really nice. And it's not too bad. So we're trying to find those places where he crosses the x-axis. We're trying to find those zeros, okay? And again, we have the scenario where, going up from above, we have one solution, two solutions, or no solution, okay? And the discriminant, or that number that's inside of the square root, will tell us how many solutions we have based upon whether it's a positive number, a negative number, or 0, okay? So I'm just going to read this little blip right here. The quadratic formula can solve all quadratic equations, okay? So if all else fails, you can't always factor, but you can always use the quadratic formula. If you have problems factoring or completing the square, we didn't go over a review on completing the square for one of these end of section reviews, but completing the square is another option that we can do besides factoring. But the quadratic formula is the one that, my upper level math kids, like my trig kids, my calc kids, they resort to the quadratic formula rather than completing the square if factoring doesn't work, okay? So there's two examples. We're going to go through each one of these. We're going to find where those zeros are, if there are any, and see what we get as an answer here. So what I'm going to do, I need to still make sure that all of my three pieces are on the same side of the equal sign. So this 15 needs to be bumped over to the other side. Instead of bumping over, I need to subtract 15. Right now it's a positive 15, but I have to subtract him to get him to the other side. So that's going to cancel out on the right side, which means I just have a 0 over here, okay? Now don't try to take the 15 away from the 2 because the 2 has an x and the 15 doesn't. So we're just going to write them side by side. X squared minus 2x minus 15 equals 0, okay? Now technically this is one of the, this guy is a simple trinomial. He could be factored down. We're going to do that here in just a second. I'll show you kind of what that looks like. But we're going to do the quadratic formula to him just for some practice on that. So I'm going to list out my A, B, and C, and we'll go through and we'll find out what these values are. Okay? So A is, let's see, in here in the equation, I have a 1, kind of an understood 1 in front of that x, so I have 1 there. B is negative 2 and C is negative 15, okay? And now I'm just going to plug them into the quadratic formula up here. So negative B. If B is already negative, this would be like negative negative 2, okay, which turns that to a positive 2. So I have positive 2 plus and minus square root. B squared is going to be negative 2 squared, so I'll write that in there. Minus 4 times A is 1, and C is negative 15. So there's that. And then I have all over 2 times A, which is 1. Okay, so I'm just plugging those numbers in there. All right, let's go down to the next line. Let's see what we get. We have 2 plus and minus, okay? And let's figure out what some of this stuff is in here. So negative 2 squared is going to be a positive 4, okay? Then if I have 4, or negative 4, a positive 1, and a negative 15, that's 2 negatives, which is going to make a positive, okay? And then 4 times 1 is 4. 4 times 15 is 60, okay? So I have 4 plus 60, which is the square root of 64, okay? And the square root of 64 is just 8. So down here, after all is said and done and everything pops out of the square root, I just have 8. And then below that I have divided by 2. 2 times 1 is 2, okay? So now this breaks into 2 pieces. My discriminant here, the stuff that was underneath of the square root, the discriminant was actually 64, because before you take the square root. That means he's positive, so that means I'm going to have 2 solutions, okay? My 2 solutions are going to be 2 plus 8 divided by 2 and 2 minus 8 divided by 2. That's where the plus minus comes from, okay? So let's figure out what each one of them is. So 2 plus 8 is 10 divided by 2. That's going to give me 5, okay? 2 minus 8 is negative 6 divided by 2, which is negative 3. So those are going to be my 2 places where he crosses. So if I look at this on the graph, 1, 2, 3, 4, 5, he's going to cross here, and at negative 3, he's going to cross here, and he's going to be a smiley face because it's a positive x squared, so looking something like that, okay? Now, if I look at this piece to start with, after I move the 15 over, he's a simple trinomial, and what I could have done is broken him into 2 separate pieces. What can you multiply to get 15, but when you add them to be negative 2? That's x minus 5 and x plus 3. Right? I need the 5 to be negative, but then when I set them equal to 0, this will be x equals 5, just like I have here, and x equals negative 3, just like I have here, okay? So it was a lot shorter factoring. That's what I want to do if I can factor, but if all else fails and I can't, because there will be some scenarios where you can't factor, you're going to be able to use the quadratic formula always and figure out what those numbers are, okay? If you can't factor and you resort to using the quadratic formula, these should always be decimals in here. But since we came out with whole numbers, we kind of know that we could have probably factored to start with. So if these numbers ever come out as whole numbers, then that means you probably could have factored, okay? So number 2, this one's already set up ready to go for us because it's equal to 0. So we want to just use the quadratic formula to solve this guy. So I'm going to list out A, B, C. Again, you could probably do this without listing it out, and that's okay, but I always do this just for my sanity. A is 2, B is 7, C is negative 1. Don't forget those negatives when they go with them, okay? All right, so negative B. B is positive 7, so I'm going to change that to negative 7, negative B, plus minus square root. B squared is going to be 7 squared, minus 4 times A is 2, and C is negative 1. Okay, all over 2 times A, which is 2. All right, let's go ahead and simplify some things. So 7 squared is 49. I have negative 4, positive 2, negative 1. 2 negatives are going to make a positive. Okay, and 4 times 2 is 8, times 1 is still 8. So I've got that going on. 49 plus 8. Okay, and that's still underneath the square root. Okay. 49 plus 8 is the square root of 57, I think. No. Yes, 57, square root of 57. Okay, now the square root of 57 doesn't come out nicely. So I'm gonna write this as 2 separate deals. The square root of 57 doesn't come out nicely. I can, let's see, can I break 57 down? Is there a number? Normally we try to do this, which I think we practice in the next review section. Is there a number that goes into 57 that I can take the perfect square root of, like 4 or 9? 4 doesn't go into 57, 9 doesn't go into 57, 16 I don't think goes into 57. So maybe we just have to leave it as the square root of 57. Right? So let's just do negative 7 plus and minus the square root of 57 all over the bottom number will be 4. Okay? So sometimes they'll have you leave your answer like this, but what I can do is I can separate those into 2 solutions, And I can put those as decimals if I want to do it that way also. So what I'm going to do, I'll show you how to enter this into my calculator here. We'll practice typing these into decimal form. Okay, so I'm going to start and I'm going to do parentheses on the top. So I'm going to open up my parentheses. I'll do -7. I'm going to start by doing plus the square root of 57. Okay, and because it opened up a parenthesis there, I've got to close the parenthesis. And then I've got to do another parenthesis close to close off that top part. So that's all of this top here divided by 4. Okay, so that's what he's going to look like. So that was me adding the square root of 57, and I got 0.14, let's say, 137, so 0.14. Okay, now, because I have this entered in all at one shot, and I want to do -7 minus the square root of 57 now, I can go back up into my equation and hit the over key and go to where this plus sign is, and I can change it to a minus instead. Okay, and then I can hit enter again. I don't have to retype everything. My second solution is going to be -3.64. Okay, so that's what he will look like. So if I convert those to decimals, that can give me a better idea of how to graph this thing. So I have 1, 2, 3, 4. 0.14 is going to be about right there, just a little to the left of 0. 1, 2, 3, 4. -3.64 is going to be about right there, somewhere in between -3 and -4. Okay, and this is going to be a smiley face again because 2x squared is positive, so he's going to do. I'm going to go off the page, something like that. Right, that's where he's going to cross the x-axis. Okay. So a lot of times I'll have you leave your answer as this, but just keep in mind that that does mean that there's two numbers. They're just going to come out as two ugly decimal numbers. Okay, and that's okay for your quadratic formula. Okay, so there's some examples of how that kind of works out. Let's go to this sheet and let's talk about here. What's the formula for the discriminant? That's that b squared minus 4ac. That's just the stuff that's underneath. What does the discriminant tell us about the equation? The number of solutions. Okay. And then let's talk about why do we use the quadratic formula, number 5. What is the quadratic formula? That's going to be that equation, and you should probably have that memorized at this point. Think of the song or think of the riddle that we talked about. What do we use the quadratic formula for? Finding the zeros, okay, which is where he crosses the x-axis, so the x-intercepts. Okay. What are the benefits of solving a quadratic equation by the quadratic formula over the other methods that we have? Using the quadratic formula is the same method every single time. You're finding A, B, C, and it doesn't ever change from there, whereas like factoring might, there's 4 different types of factoring, so that one's kind of, hard to remember which type of factoring method to use at certain points. Okay, so the quadratic formula, A, B, C, you would plug them in, and it's pretty easy from there. Okay, so that's what I would say for number 5. All right, and I'm going to go ahead and stop there. That's quadratic formula.